So welcome everyone. Let me introduce the topic of my PhD, the role of gut microbiota in cystic fibrosis. My name is Blanka Bódy. My vision is to offer a complication-free life for people with cystic fibrosis by investigating the role of gut microbiota in the disease. So here you can see the list of my projects. Let's jump to my first project. The comparison of gut microbiota in cystic fibrosis patients and healthy individuals. So between 70,000 and 160,000 people are living with cystic fibrosis worldwide. This number is the highest in the European decent population. So here you can see the gut wall of a healthy individual and a cystic fibrosis patient. So the CFTR channel in a healthy person works just fine, providing a normal environment for the gut microbiota. However, in a cystic fibrosis patient, the CFTR channel is dysfunctional. This results in various local and systematic complications as well, including a continuous inflammatory cycle. So our aim is to investigate the role of gut microbiota and to measure the differences between CF patients and healthy individuals. So our clinical question is, how does gut microbiota differ in cystic fibrosis patients and healthy individuals? Our outcomes are alpha diversity, measured by different indexes, beta diversity, and the abundance of certain bacterial species. We conducted our systematic search in 5 databases. You can see our search key here as well. At the end of the selection process, we ended up with 15 eligible articles, and we found 2 additional articles at the end of the citation chasing. So we finished analyzing our first main outcome, alpha diversity, and we also conducted a subgroup analysis according to age. Our 2 other main outcomes are yet to be analyzed, relative abundance and beta diversity. So before we jump into our results about alpha diversity, our first main outcome, let me tell you a few words about alpha diversity. So it is microbial diversity of one given sample. It is subdivided into species richness and evenness. Richness meaning how many bacterial taxa are found in that given sample, and evenness is how evenly these bacterial taxa are distributed. So alpha diversity can be measured by different indexes, and Shannon index is one of these. Shannon index takes bacterial richness and evenness into consideration as well, putting more weight on the richness. It can range to infinity. However, the normal population is thought to have a Shannon index between 3 and 5. Our effective measure is standardized mean difference. We had to standardize the mean differences between the CF and the control group because as you calculate alpha diversity, you have to take into consideration the number of bacterial species you have found in that given sample. And as this number differs between samples and, of course, articles, we had to standardize this measure. We only included case control articles, and we created subgroups according to age, as I've mentioned before, subgroup of infants, children, and adults. Let's jump to our first result in the subgroup of infants. So standardized mean difference is 0.05, which indicates there is no difference between the CF group and the control group. The reason for this result can be the younger age of the participants as well as different delivery methods. However, in the subgroup of children and adults, standardized mean difference is minus 1.21, which indicates that the microbial alpha diversity of the CF group is less diverse than the control group. This result is clinically relevant and statistically significant as well. So our second alpha diversity measure is the SHA-1 index. This takes only bacterial richness into consideration, putting more weight on the less abundant species. Also, as the values get higher of SHA-1 index, the diversity gets higher. These 2 subgroups where we had articles from are the children and adult subgroup. And the one article in the children subgroup supported our findings in the adult subgroup that alpha diversity measured by SHA-1 index is decreased in the CF group compared to the control group. Our third alpha diversity measure is observed O2s. This only takes bacterial richness into consideration. This is the simplest of all alpha diversity indexes. It basically just counts up the bacterial taxa that was found in that given sample. We had articles from the children and the adult subgroup, all in all 6 articles, 3 in both subgroups. Looking at our result, we can see that alpha diversity in the CF subgroup is decreased compared to the control group. However, these findings are not mathematically significant. So as our strength, I can mention that we analyzed age-related differences as well as various alpha diversity indexes, and we have a higher evidence due to the larger overall sample size. However, we also have limitations. For example, the high risk of overall bias of our articles, and we only have articles from high-income countries, and we could not conduct an ethnicity-based subgroup analysis due to the lack of data. In conclusion, I can say that cystic fibrosis serves as a barrier to the diversification and maturation of the gut microbiota, with notable age-dependent variations in microbial composition in the CF population. So as for our implications for practice, I can mention a closer monitoring of the patients. As for research implications, the investigation of therapeutic microbiota modulation, as well as different CF-related factors' influence on the gut microbiota. This is where we are with our first project. We have analyzed our first main outcome, and our 2 other main outcomes are yet to be analyzed. In our second project, we are investigating the gut dysbiosis in cystic fibrosis patients according to glucose tolerance status. So cystic fibrosis-related abnormal glucose tolerance is present in every 3rd child. It is the most common extrapulmonary manifestation. So we have the dysfunctional CFTR channel, which results in various complications and consequences, including dysbiosis. Dysbiosis is partially responsible for a continuous inflammatory cycle, which plays a key role in the development of cystic fibrosis-related diabetes. Let's see how dysbiosis is associated with type 1 and type 2 diabetes in the literature. So it is thought to have a connection with type 1 diabetes through immune modulation and the leaky gut, and to type 2 diabetes through various metabolic pathways. So our aim is to investigate the association of gut microbial changes and glucose tolerance. Our question is, what are the main differences in gut microbiota in children with cystic fibrosis-related abnormal glucose tolerance compared to children with normal glucose tolerance? Our outcomes are the same, beta diversity, alpha diversity, and the abundance of certain bacterial species. And our hypothesis is that dysbiosis is associated with cystic fibrosis-related abnormal glucose tolerance. So our source of data is the Cystic Fibrosis-Related Pancreatic Disorder Registry at Translational Pediatric Institute. Our first task is database filtering. Here you can see our inclusion and exclusion criteria. Inclusion criteria are children under 18 years of age with cystic fibrosis diagnosed. They have to have a stool sample available as well as the result of an OGTT. Our next task will be data cleaning, followed by microbiota analysis at the Institute of Medical Microbiology. And then comes a biostatistical analysis of the data that we have. Here you can see the funding that made this project feasible. So in summary, in my 2 projects, I aim to investigate the role of gut microbiota in cystic fibrosis patients. So I want to thank you for your attention with the quote, "The man who moves a mountain begins by carrying away small stones." Thank you.
Thank you for your presentation. I would like to ask about your first topic. What was the reason of the high risk of bias?
So one of the reasons was the non-matched groups. So there were different reasons for that, not matching for age, for sex, for the number of participants that was particularly prevalent. So many studies did not adjust the number of participants. Then we had an article where the CF group and the control group did not come from the same continent, so there was also a bias. What else? Many articles did not mention how they dealt with the confounding factors, or they did not mention if they had any confounding factors. So these were the main biases that we had.
Congratulations to your excellent presentation.
Thank
My
you.
question is that what are the factors that contribute to dysbiosis in cystic fibrosis?
Thank you for the question. We have to divide the answer to cystic fibrosis itself and to the treatment. So as for the treatment, constant antibiotic exposure is one of the reasons, as well as high-fat diet. As for the disease itself, there is the altered bowel movement that could contribute to dysbiosis, as well as decreased pH of the intestinal lumen. So these are the factors.
Thank you for your presentation. My question is regarding your first project. You mentioned as an implication closer monitoring, but however, your results clearly show that there is decreased gut microbiota in cystic fibrosis. So what would be your clinical implication? What would you do different as a physician to improve this?
Thank you for the question. So we were cautious with forming the implications because we do not have all of our results yet. So one of the main outcomes is abundance of certain bacterial species. And this is an important outcome as we wanted to see what bacterial taxa are less prevalent in the gut of cystic fibrosis patients, what are more prevalent. And seeing these patterns, it is feasible to modulate the gut microbiota of CF patients. I think it is a key information in doing so. So this is why we are very cautious with forming our preliminary implication.
I understand. And one more question. Did the articles mention what does healthy population mean? So are any comorbidities excluded, and what kind of diet do they have? What kind of exercise are they doing, and so on?
We included a population for control where no factors that could influence gut microbiota were present. No kind of drugs that could influence gut microbial composition, no diseases that could make a difference. As for characteristics of these patients, we paid attention that they are at least matched by age with the participants in the CF group. But as for exercise and diet, the articles did not give much of an information.